Welcome to Learn SQL Basics Part 6 Advanced. In this video, we dive into powerful SQL concepts to help you write smarter and faster queries. Take your data skills to the next level.
Let's understand SQL window functions in a simple way. So, what exactly are window functions? A window function performs calculations across multiple rows that are related to the current row without collapsing the data. This means you can analyze trends while still keeping each row intact. For example, you can calculate running totals, like summing all previous rows up to the current one. You can also compute moving averages, such as a 7-day rolling average, and even generate rankings within your dataset. Now, how is this different from aggregate functions? Aggregate functions, like those used with group by, combine multiple rows into a single row, but window functions don't do that. Instead, they return a value for each row while still considering other related rows. That's the key difference. So remember, aggregate functions summarize data, while window functions enhance each row with additional insights. And that's why window functions are so powerful in SQL.
Let's break down the syntax of SQL window functions. First, window functions are defined in the select section of your query. Here's the basic syntax. Select window function over, partition by, partition expression, order by, order expression, window frame extent as window column alias from table name. Now let's understand each part. The window function is the function you want to apply, like row number, sum, or AVG. Partition by is optional. It divides rows into groups, similar to group by. Order by is also optional, and it sorts rows within each partition. Then we have window frame extent. This is optional too, and it defines the frame of rows, like rows or range. Finally, as window column alias gives a name to the result column. Now there's another powerful concept. If you want to reuse the same window across multiple functions, you can define it using the window keyword. This is written after the order by section of the query. Here's how it works. Select window function over window name from table name, having condition, window name as partition by partition expression, order by order expression, window frame extent, order by column name. In this case, window name is simply the name of the window you define. Partition by groups rows, just like group by. Order by sorts rows within each partition, and window frame extent defines the frame, like rows or range. Using the window keyword helps you write cleaner and more reusable SQL queries. And that's the complete syntax of SQL window functions. Let's understand how partition by works in SQL window functions. We can use partition by together with the over clause to specify the column over which the aggregation is performed. Now, let's compare partition by with group by to understand the similarity and difference. Just like group by, the over subclause splits the rows into as many partitions as there are unique values in a column. However, there's a key difference. While group by aggregates all rows and returns a single result per group, a window function using partition by aggregates each partition independently without collapsing the rows. And here's something important to remember. Without the partition by clause, the entire result set is treated as one single partition. So partition by helps you group data logically, while still keeping every row visible. That's what makes it powerful in window functions. Let's understand window functions with partition by using a simple example. First, using a group by clause, we can calculate the average price of bicycles per model year. Here's the query. Select model year and average of list price as average price from products, group by model year.
This gives us aggregated results like, for 2016, the average price is $980.22. For 2017, it's $1279.91. For 2018, it's $1648.67, and for 2019, it's $2583.32. Now, what if we want something more powerful? What if we want to compare each product's price with the average price of its model year without losing individual row details? That's where window functions come in. We use the average function with over and partition by. Here's the query. Select model year, product name, and average of list price over partition by model year as average price from products. This keeps every product row intact while also showing the average price for its year. For example, in 2018, Electra Amsterdam Fashion 3i Ladies has a price of $802.99, while the average price is still $1648.67. Similarly, for 2017-2018, Electra Amsterdam Fashion 7i Ladies is priced at $1299.99 with an average of $1279.91. And in 2017, Electra Amsterdam Original 3i is $659.99, again compared with the same yearly average. Finally, notice something important. The average price for 2018 remains exactly the same whether we use group by or partition by. The key difference? Group by aggregates and reduces rows, while partition by retains rows and adds insights. And that's the power of window functions in SQL. Let's explore how order by works inside window functions. Order by is a subclause within the over clause. It determines the order in which rows are processed and changes how functions assign values like ranks or row numbers. This is especially important for window functions like rank and row number, where sequence matters. For example, if we order by the column price in ascending order, the lowest priced item gets the lowest rank. Now let's look at two scenarios. First, ranking prices from high to low. Here's the query. Select product name, list price, rank function over order by list price descending as rank from products. In this case, the highest priced products get the top ranks. For example, Trek Domain SLR 9 Disc 2018, priced at $11,999.99, gets rank 1. Trek Domain SLR 8 Disc 2018, priced at $7,499.99, gets rank 2. Trek Domain SL Frameset 2018, priced at $6,499.99, gets rank 3. Now, let's reverse the order, ranking prices from low to high. Here's the query. Select product name, list price, rank function over order by list price ascending as rank from products. In this case, the lowest priced products get the top ranks. For example, Strider Classic 12 Balance Bike, priced at $89.99, gets rank 1. Sun Bicycles Lil Kitten 2017, priced at $199.99, gets rank 2. Trek Boys Kickster 2015/2017, priced at $149.99, gets rank 3. So what's the key takeaway? The order by inside the over clause controls how rows are ordered, which directly impacts how ranking and sequencing functions behave. Ascending order highlights the lowest values first, while descending order highlights the highest values first. And that's how order by powers window functions in SQL.